video with all the structural design of the basement revisions, floodproofing revisions. We also have James Showalter and Chris Rose from the inspections department here as well. James will be presenting here later. First, since some of you may have not seen all what's been going on with the city and the recent changes, I thought quick just give a brief overview of everything that's been going on in the city lately. Hopefully most of you know this past January FEMA now has a new floodplain in place for the city of Fargo that's based off of a river stage of 39.4 feet. The flow in the river at that elevation would be 29,000 cubic feet per second. 1 cubic foot per second equals about a basketball. So on that peak elevation at a 39.5 foot flood, we got 29,000 basketballs going by every second. With this new floodplain, we got about 2,500 impacted structures. Previous floodplain, the 38.5 feet, had about 400 structures impacted, so you can see about that foot of rise with our flat terrain brings in additional 2,000 structures. The flood record was in 2009 at 40.8 feet. Most of you probably lived through that, at least hopefully you lived through it. And then future of the floodplain. We know that the recent revised floodplain, that 29,000 CFS or 39.4 that FEMA just passed, is probably not accurate. The reason for that is the new map only had the hydraulics updated of the river. It didn't look at the hydrology of the river. FEMA did not update the hydrology. So they're using hydrology that's based off the 70s and 80s. And hydrology is basically the amount of water entering the river system. So they only looked at how the river functions, not actually how much water is getting into the system. Part of the diversion, though, the Corps of Engineers actually looked at the hydrology, looked at all the most recent data, and determined that really our area's 100-year floodplain risk is probably closer to that 41-foot elevation. So as you'll see here later on, that's really what a lot of the city is looking at now, is that 41-foot elevation, due to that's our true risk. And without the diversion, there's only a matter of time before we do get remapped to that 41-foot. If we did get remapped to that 41-foot, we'd have just a little over 19,000 structures being impacted. So quite a bit more structures would be brought into floodplain with that 1.5 rise. So what does that 39.4 floodplain look like? On the left hand is what it is. On any area you see it blue, so 94 sits right here. Anywhere you see the blue is that new floodplain. On the right hand side is what the 41-foot looks like. So at that point you can see water starting to travel through the core of the city to the 41, and we're starting to see a lot more blue on the south side of town. What would it look like with the diversion in place? On the left is diversion in place. With diversion in place, we'd have flows come through town at that 100-year flood at 35 feet. So for the most part, all the water would be contained within the river itself. And there'd be some still south of the diversion alignment. This black line here is the diversion alignment. And then there'd still be some backwater up in the north. But the core of the city, for the most part, would be dry. Again, on the right-hand side is that 41-foot, just for a point of reference. So, as you all know, the river likes to flood here quite a bit here lately. Our river stage, minor river stage, is 18 feet. That is when Elm Street goes underwater, so that's the first road impacted in the city, so that's why it's classified as minor flooding at that point. We don't have any properties impacted until potentially around 38 feet, but 18 feet we do have infrastructure impacted. We've exceeded that level 50 of the past 111 years, and actually every year since 1993 with the exception of 2012. We're getting close to it even today. I think we're just shy of 17 or a little over 17 right now, but it doesn't look like we're going to get there. We have been able to avoid the catastrophic damages by extensive emergency measures. 8 of the past 16 major floods. A major flood is a river stage at 30 feet. That's when we have to do something first on 2nd Street down by City Hall and High Rise. 8 of the past 16 of those have occurred since 2000. So you can see how we are in that wet cycle right now. Again, 2009 flood record, 40.8 feet, and the costs of the emergency measures during that flood fight, of those about 10 days, was $70 million. So it was a rather expensive flood fight. In case you weren't around, or just to relive a little bit, in 2009, the city of Fargo in those 10 days put up about 52 miles worth of protection along the river and the drain corridors. So we did a lot of efforts. That consisted of 29 miles of clay levee, as well as the county did 5 miles, 8 miles of HESCOs, and then 10 miles of sandbag levees. After the 2009 flood, City Commission directed us to look at a comprehensive plan for the entire city corridor. What it would take to remove properties from that new floodplain that just became effective this past January. From that, we identified about $247 million worth of project needs. So we looked at areas, only areas that would are being impacted by the new floodplain. So you can see wherever there's a black line along here is the area where we identified the project to occur. You can see there is some gaps, so, and those are areas that are above the 100-year floodplain but not above that 41-foot elevation. So I'll touch base on that a little bit here. So to date, we've really been concentrated on this yellow area. With the funding that we had available, we had to prioritize, and that yellow area is the area that has the largest impacts. We have about 1,500 structures being brought in there alone. The yellow area is basically north of Drain 27, north of the Rose Creek Golf Course, and again, 94 sits right here. So why implement the comp plan? Short term, for every foot of levee or flood wall we get constructed, there's less we have to do in the spring. It's less emergency efforts needed. As soon as we get that protection in place, we've got real protection for existing homes nearby. Long term, there's kind of 2 phases to why we want to implement it now. First would be getting that certifiable line of protection and starting to remove properties from that new 100-year floodplain that just became effective this past January. Then, in addition, even with completion of this whole project, it would also complement the diversion quite well once the diversion is in place. With diversion in place, again, on that 100-year elevation, we see flows coming through town about 35 feet. But if we experienced the 500-year flood, similar to what Minot experienced a few years ago, we'd still be having flows coming through town around that 41-foot elevation. So while these projects would no longer be necessary for the 100-year flood, it will definitely give us that true 500-year protection in our community that we're looking for. Since 2009, the City of Fargo's acquired over 173 properties. The cost of that was $57 million. The county's also purchased 14 properties that were necessary for a City of Fargo project. The county's purchased a lot more than just 14, but only 14 that the city needed for one of our projects. And then the diversion authority is in the process of acquiring 15 additional properties as well. Those are for the most part all downtown. Even with the 173 properties that have been purchased, we'd still have 121 more properties to be acquired to complete that comprehensive plan. So we still got a little ways to go. Since 2009 though, we've completed over 16 miles worth of levees. The project cost of that was $82 million. With getting those 16 miles of levees completed, we reduced our sandbag needs for a 2009 event by about $4 million. So we put a significant dent in it, but I think we had about $6 million out on the ground in 2009. So we still got a little ways to go. Along with the 173 actual full property acquisitions, we also purchased 80 private property easements. Those are property owners that are now living with levees or a flood wall in their backyard. So our community's been very receptive to getting these projects completed and living with these projects in their backyard. Here's just one project that we completed last year, Rose Creek. If you guys are golfers, you probably have seen this ongoing for the past couple of years. This has been a successful project that reduced our sandbag need in this neighborhood alone by about $400,000. Just for a refresher, this is what it looked like in 2009. So we're trying to avoid this. It was quite the disaster out here, as well as a lot of other places in the city. So in progress, right now, the City of Fargo has 6 projects either under construction or design. I'm sure if you drive around town, you're seeing them all over the place, whether it's along 40th Avenue or River Drive or University Drive, any of there. The Diversion Authority also has 6 in progress as well. Those are for the most part downtown right now. Between these 12 projects, we have 3.5 more miles that are in progress. The cost of these 3.5 miles is $100 million. So you can see that previously we had just a little under $100 million to get 60 miles completed. Now we're at $100 million to get 3.5 miles completed. So we picked off the easy ones. We're starting to tackle the more harder, technically difficult ones. Once we get these projects completed, we'll be at 55% of that comprehensive plan completed. Even with those 3.5 completed, we'd still have over 13 miles worth of projects to be completed to complete that entire comprehensive plan. The updated project cost for those 13 miles will be about $240 million. A lot of that cost is the actual interstate raise right by Fleet Farm. In order to create that certifiable line of protection, we actually have to physically raise the interstate. So there's 4 bridges there that we have to redo. You'll possibly see that going on in as early as next year. So even with completing this entire comprehensive plan, though, I want to point out that we'd still have some emergency measures to be completed if we had 2009 flood tide on our hands again. That's because all these projects are tying into that 39.5-foot elevation. We know in 2009 we protected to 44 feet, so there's a lot of areas that we'd still have to go fill those gaps. So we have about 7.5 miles of clay levees to complete and 3 miles of sand lake levees. A lot of these areas we can't complete permanent projects, so that's why diversion is so crucial for us to, for our community and our region. What does a comprehensive plan look like, or a certifiable line look like? I thought I'd throw this in here quick. That this is reflecting anywhere you see that red, blue, or the dashed lines is larger levee system that needs to be fully completed in order to remove that blue area, or was shown as yellow before on that one map. So we're up at 32nd Avenue here. We got to go all the way along the river, along the north side of Rose Creek Golf Course, which we already have that completed, through here, over by Fleet Farm, cross the interstate, raise the interstate, and at this point over by the new West Fargo Elementary School, we should be able to go and tie up and hit high ground over there. Once we get that entire levee system completed, then we can hopefully remove those properties from the new 100-year floodplain. So we're probably looking at 2018 to get to that point, so we are getting close to reaching the end, but we still got a lot of work left to do. But this just is trying to show how flat we are and how difficult it is to complete those certifiable lines of protection. So now going into the kind of the construction requirements that the city of Fargo has for new developments. We require all new developments that are in the new floodplain to be elevated to at least at 39.4. We want them to be elevated in such a manner that they'd be eligible for a FEMA LOMR F, which is a letter of map provision based on fill. As long as it is successfully done, the flood insurance would no longer become mandatory for those property owners. They'd be able to purchase flood insurance at the lowest possible rate if they chose to purchase it. So like I said, we require this all new developments to elevate and remove themselves from the new floodplain. Here is just kind of a screenshot of what we have on our website that anybody can go view. We have what areas you can go view, what areas have been successfully removed from LOMR. So anywhere where you see these purple, pink areas, these areas have been removed from the LOMR. You just want to make sure you check the current effective floodplain and then have this LOMR information turned on. So we're looking at the Eagle Point area right here. The reason that these are shown in the floodplain is because it's currently under construction right now. So a year from now, when you pull up this map, you'll see similar pink areas through there. But so any areas that you don't see this pink areas though, and it's blue, you're in the 100-year floodplain. So flood insurance would be mandatory. About a year ago, City Commission took the proactive approach of changing elevation requirements of when a floodproof basement is going to be required. Due to, like I said before, we know that our 100-year floodplain risk is probably really the 41-foot elevation. We want to best position any new construction that if we ever did get remapped to that elevation, that flood insurance, while may not, the need may not be eliminated, they still may need to pay the flood insurance, they'd be able to pay it at a much lower rate with a floodproof basement and being elevated up at a higher elevation. So a year ago, City Commission passed the 41 plus 1.2. Recently, here I guess in March 2014, City Commission passed that 41 plus 1.2. that any property located within that 41-foot inundation area must have a floodproof basement. Like I said, the change was recommended due to the modeling completed under diversion, showing that our 100-year floodplain risk is at 41 foot. However, over the past few months since the new floodplain has been effective, we've seen some elevation discrepancies that we weren't quite meeting the state's, or barely meeting the state's elevation requirements of base flood elevation, which is 39.4 plus 1, when we were using the 41 plus 1.2. So due to the closeness of barely meeting the state's freeboard requirements, this past April, City Commission actually approved a policy update to it. We're still requiring 41 plus 1.2, or the FEMA BFE, the 39.4 plus 2, whatever is higher. For the most part, the 41 plus 1.2 is going to control all the time, but there is a few areas where the FEMA BFE plus 2 is going to control. We don't see really a significant cost increase at all to this, because remember, we're setting all the top of the curbs out there at the BFE. So we're talking 24 inches above the back of curb, which is kind of common building practice to begin with. The reason for the discrepancy between the two is the different models that were used. The Corps used a different model of steady state, where it allows water to flow more places than what the FEMA model they created. So that's the different elevation requirements. I won't get too in depth on that. So why did we change this policy a year ago, and then even this recent revision? Like I said, flood insurance premiums, well, like I said, it's all due to the uncertainty of our floodplain in this region. We know that if we get remapped at that 41 foot, we want to best position these new constructions. If we did not have a floodproof basement and we got remapped at that 41-foot elevation, and they were now in new 100-year floodplain, which there's 2,500 structures in the exact same situation today, their point of risk is going to be on the basement floor if they're not floodproofed. That's how FEMA recognizes basements. They will consider you basically 8 feet in the ground, even though your ground elevation may be right at that 39.4. They're going to consider you 8 feet down. So by having a floodproof basement, though, they're going to consider your point of risk the top of the basement wall. So now all of a sudden you're going to be 41 plus 1.2 up. So now instead of paying $3,000 to $4,000 in flood insurance premiums if you're in the 100-year floodplain, you're going to be paying $400 to $500. So there's a significant cost difference. A good investment for any folks that may get brought into the floodplain. You'll get a return on your investment pretty quick. One other thing that we did change this past month, we actually decreased some elevation requirements a little bit on the non-primary detached accessory structures. So that's a garage, a shed, as long as it's not attached to your primary structure. We lowered the elevations. Now you're no longer to go 41 plus 1.2. You can go the BFE, that 39.4 plus 1 foot. So that is a little lower elevation there. The reason for that is the National Flood Insurance Program, Congress changed it last year, and FEMA's just finally started to implement some of it, and they're showing that, or they're determined that in the accessory structure, like a garage, if it's in the floodplain, will not make flood insurance mandatory. So due to that, we felt that we don't need to elevate those structures up to higher elevation, because if we ever got remapped at that 41-foot elevation, and that structure was in the floodplain, it would not force flood insurance on that property owner. So how do you see these 41-foot maps? This can be the same, same for looking at the 100-year floodplain or the Lomer areas. Go to fargofloodinsurance.com. On the main homepage, you want to search flood maps, click on that link, bring you this map. You want to click on the interactive GIS map. You pull up that, and this is what you'll ultimately be looking for. You want to check on the 2014 imagery if you want to look at any of the structures, and then check on that 41-foot water surface elevation inundation area. Any area you see the blue hatching is an area of the 41-foot water pool would be at that elevation. So again, if that property is touched by that blue hatching, you're going to be required to have a floodproof basement. again, here's that current effective floodplain map, so if you want to see if it's been the lowered area or not, you can check that as well. So why is the basement exception so important to the city of Fargo? Basically, the basement exception allows us to build basements. If we did not have the basement exception, FEMA would not allow us to build basements in any property within that special flood hazard area or the 100-year floodplain. We originally received approval from FEMA for this basement exception back in 1975, so we've had it for quite a while. It's something FEMA doesn't really like to give out too much. Throughout the entire country, I think there's 56 communities that have the basement exception. So it is important for the city of Fargo to have it, as well as this whole region. The reason why it's so important is, it provides that safe location, in case of a tornado. But it also reduced cost of fill need being imported to the lot. If you did a slab on grade, you're going to have to put that fill back in there. With the basement, you generate more fill on site to backfill around your home. Then you're also able to add additional square footage to the structure at a lower cost. This is, again, due to the region that we live in. You guys know more than I do. We're down at least 5 feet or so on the ground, regardless whether it's a basement or not, to make sure we get below that frost level. With that, I'll turn it over to Casey, and she'll actually go through the actual design changes.
Thanks, Dave. I'm going to use this. Okay. So I know I'm probably the person you want to see the most, just to figure out what's going on, why these changes came about, and what we can do to help explain them further, make them simpler to use, get a little more understanding as to why they are what they are. So, as Nathan mentioned, in 1975, this code was originally adopted. It has not been changed since then. So everything that we're using is based on, 30 years old. There's been a lot of updates, a lot of research done, developed, as far as just overall construction methods. So it's important that we take a look at this on a regular basis, and we just haven't been required to, solely on the fact that FEMA hasn't requested it. Is that correct? So everything we've done up to this point has been based on 1975 standards. And if you actually look at it, the City of Fargo code, the building code, is much more strict than what the 1975 code is. So what we did when we came on board, we were asked to take a look at the building code requirements, the state requirements, and the core requirements. So just a lot of different things, put it all in perspective and figure out how we can make it better. So the 1975 code was based on a 1969 flood, which was actually, almost 12 inches lower than what the BFE was at that time, which is significantly lower than what we're dealing with now. They were also based on Uniform Building Code. It has been 15 years since we've used a Uniform Building Code. The 1971 Concrete Code, back at that time we were still using a lot of unreinforced concrete. The review of the system really didn't take a look at the whole building as a whole. It really focused on the physical properties of that concrete wall. And they also took a look in consideration at the actual damage that was visible from the 1969 flood, which really wasn't total damage, so to speak. It was a lot more related to, they saw a lot of cracking that had occurred in the basement walls. So that was one of the main things they took out of their review was, anything that wasn't reinforced, because reinforcing was not a very common practice back then. So anything that wasn't reinforced, they really saw that there was issues there, which there were temperature and shrinkage cracks, and we needed to focus on that. So reinforcing was recommended then with the 1975 code. So updates to the new design guide. It's based on the current elevations that are put in the City of Fargo code. It follows the current building codes, so all of the codes that you see up there, that's what we base this on. Provisions, they're based on the Army Corps of Engineers, their floodproofing requirements, so we did take a look at that. We did focus a lot of our attention, as you probably have already seen, on those actual connections to make sure we've got a solid structure and we're transferring loads to the entire system. One thing that was not included in the previous code, just based on the new types of construction we have, bi-level basements or bi-level construction wasn't considered. So I think everything you've done up till this point has really been based on a basement construction and just taking them and applying that to the bi-levels, which really we'll look at it. They do function differently, so we need to have two different approaches. And contrary to what people believe, this really was a collaborative effort. We sat in this room with the City of Fargo, Braun, myself, the Home Builders Association, and really tried to come up with a collaborative solution. What's going to work best? How can we make this better? We know there's changes. What can we do to minimize that and really, hopefully, embrace the process? So included in our analysis, one thing we did with Braun was Braun ran a seepage analysis on the soils that we have in the area. And what they found was that with our soils here, they're very impermeable. So it's going to take a long time for that water to actually get to a basement structure, assuming that all of the setback requirements are met and you're putting back the clay that came out of the soil and it's compacted. Lateral earth pressures, what is that? It's basically the pressure that's applied to the basement wall. We came up with, there's a lot of different values out there, but based on all the information we had, we concluded that 65 pounds per cubic foot of active pressure is acceptable to be used. There's research that shows up to 120 pounds per cubic foot, which you can only imagine, that's double that what we're dealing with now. That would significantly have changed the design approach. The key with that is, due to the seepage analysis that was done, we're not considering a fully saturated condition. So that has to do with the actual soils we have in the Fargo area, which are helping us. And then in addition, everyone right now is putting some kind of drainage system in, drain tiles, sump pumps. We're making sure that water doesn't accumulate outside of the walls. So that's helping us to make sure we can use these lower values compared to what, if we were to look at the full system and just flood it, it would be significantly larger. So let's get into the actual tables. I think some of you have probably had a chance to look through this. I know it's been in place for a little while. We did have an update recently, just based on some further discussion. But table 1 is for your basement construction. So your traditional basement construction. We're looking at different kinds of wall heights, different thicknesses, different rebar sizes, trying to give, you know, it may not feel like you have a lot of options, but we're trying to give you as many options as we can. We utilize the strength of the basement wall in both the vertical and the horizontal direction. So we're trying to maximize the capacity of the wall through that. Construction options, once again, trying to give you guys as many options to figure out what's the best fit for the situation I have right now. We didn't want to force you into one method when you may have some advantages to the existing geometry of the structure to help you out. So there's two options that are presented. Case A, it basically maximizes the spacing of the connection at the top of the wall, or the anchor bolts. It minimizes the number of anchor bolts required. Case B maximizes the horizontal capacity of the wall, but so that you have less jogs in your wall that's required, or I'll show you an example of what that means. But case A, basically, we're minimizing the amount of anchor bolts because we do know we've increased it no matter how you look at it. Case B is very similar outside of that connection requirement at the top of the wall to what you're already doing with the City of Fargo code. So I apologize if this isn't real clear to see, but I just took the 7.5 foot wall from the table 1A. Again, case A, you've got that listed on the top with the different wall thicknesses, 8, 10, 12. You can see the vertical reinforcing doesn't change. That's because we're utilizing the vertical direction of the reinforcing. We're maximizing that. Case B, that's where we're back to something very similar. If you compared this chart outside of all of the bracing requirements, the anchor bolt requirements, you would see this almost is spot on what you see in the existing code today as far as the building code. So case B is very traditional to what you're constructing now outside of those bracing and the anchor bolt requirements. So table B, just because there was a lot of information, very difficult to fit it on one sheet, we broke it down into case A is where your reinforcing requirements are. Case B is, or table B is where you'll find your anchorage requirements at the top of your wall. This detail we have provided that goes along with those tables. The overall format is similar to what's presented today in the City of Fargo Building Code. So you've got your tables, you pick out what your wall height is, what your thickness is, and it gives you your reinforcing. This also has a detail similar to what's in the city document, just shows where that rebar needs to be located. It shows you the damp proofing requirements. We have damp proofing on the exterior surface of the wall as well as below the slab. It gives overall, I guess you can see the drain tile listed here at the base of the footing, your concrete slab, and then it does give you kind of the overall geometry of what the anchorage looks like at the top of the wall there, with the provision that this is specifically for when your truss or your joist bears on top of your wall. We do have the other case where the joist or the truss is running perpendicular and we still need to provide some lateral support at the top of the wall. Here's an example, because I know some of this terminology is, what is it, what does it mean for me, how do I use it? It's just a very generic example. Whether or not you actually have this, you build homes like this, is outside of the question. It's just to illustrate kind of what the requirements are. So you see we have, just a natural jog in our wall. You see that in a lot of basement constructions. And shoot, it is very fuzzy. This dimension here is 18 feet, and then we've got 17 feet. This example is based on a traditional 9-foot wall. So as long as these two dimensions here are within the maximum horizontal spans, we get by with case B along these two walls. And on the other walls here, we have a lot of window wells. So what can we do to take advantage of those? We can actually change those to a case A wall where we have less anchorage at the top of the wall that's required, because we can take advantage of the jogs in the wall. And we actually had a span in the middle here that was almost 15 feet, which was greater than what is allowed in the table. The maximum horizontal distance for a 9-foot wall under case A is 9 feet. So all we did was add a 2-foot jog. You could jog it through the overall geometry of the layout of the plan, or you can just put a stub wall on the outside surface of the wall. It can be inside as well, but it's basically a brace to help break up that long span. So we can take advantage of case A, where we have these shorter spans. We've got it broken up quite well. These walls here, they all required case B. And this wall here was like a 25-foot span. So to break that up and meet the minimum requirements or the maximum requirements in the table, we put another jog or just a little wing wall on the outside of the building. You'll also see here that we have kind of these dashed lines where the trusses run parallel to the wall. That's where your bracing requirements come into play, because we still have to prevent the top of that wall from wanting to move in. So that's where, on these walls, your trusses are bearing on it. That's providing that lateral resistance. Out here, there is nothing unless we physically put that bracing in. So this just hopefully kind of helps illustrate anywhere you have a truss or a joist running parallel to a wall, that bracing is required. And then just looking at, your options as far as, what works best for you. You want to put less anchorage in, throw some jogs in the wall, do something to help break up that horizontal span. So I don't know if this helps at all. Hopefully it does give you a little more information as to what that terminology is and kind of what we're looking at. Table 2. Now this is bi-level construction. This is something that wasn't covered in the previous versions of the code. They do not function the same as basement walls. Bi-level construction, the top of those walls, they're not braced. There's no lateral support at the top of the wall. It's just a cantilever hanging out there. So what do we have to do? If we don't brace the top of that wall somehow, now we have to kind of create a ballast with our footing and make sure that footing is big enough to prevent that wall from wanting to tip over once we load it with soil. The other thing is, with that construction, now you have the top of your wall wants to come in. Well, it does with a basement wall as well, but we're restraining it. But when you're allowing, you're not providing that restraint to the top of the wall, now you're reinforcing needs to be placed on the outside face of the wall. With the basement, it's on the inside face. So that's a key to remember as well. Bi-level construction, you're really going to be focusing on that, reinforcing on the outside face of the wall. We also understand, based on the requirements that the City of Fargo has with the base flood elevation, that you need to probably be excavating a lot deeper for these structures than just a traditional 4 or 5 foot depth. So how are we going to get by with that? The city does require us to put that on native soil. So we have put some provisions in the detail that show you what to do. You can still use the same tables, it's just a matter of continuing that footing and the wall down to that elevation you need. So here's our minimum requirements. Another thing to notice, because a lot of people are probably going to look at this and scratch their head and say, what's going on here? This doesn't make sense. I moved from an 8-inch wall to a 10-inch wall, and I have number 4s at 18 inches on center in both cases, but then I have number 5s and number 6s, those change. It's based on, we've got 2 different scenarios that we've looked at in our design. One is, we looked at the overall strength. What is required based on the strength of that wall system? The other thing, when we went back and looked at the 1975 code, one of the big things that was missing is that temperature and shrinkage reinforcing, making sure that things stayed together. So if you see some of that stuff where you're scratching your head and saying what's going on here, it's probably based on the fact that now all of a sudden you've switched from the wall capacity controlling to having to maintain those minimum requirements to help prevent that temperature and shrinkage, those cracks from forming. So, like I say, it may be a little counterintuitive, but that's really what's going on. We took a look at both scenarios and took the worst case of the 2. And that happens too in the basement design, so just so you know that. Here is a detail now that shows what that bi-level construction looks like. Once again, you'll see that the reinforcing is at the exterior face of the wall because this wall is going to want to move. So the wall can take compression, vertical force, but it's not very good when it starts to want to open up. So that rebar is there to help prevent it from opening. One thing to note is the location of the drain tile. That can be directly below the slab, or if you prefer, you can put it down at the footing elevation and put a deeper sump in. But that's, once again, your option, what works best for you. Deeper sump, might be less costly, I don't know. Might be easier to slap that drain tile in right away before you backfill. Completely up to you. The other thing is, note that there are specific requirements as far as that fill underneath that basement slab. And that is a brawn requirement. So that does have to, we can't just put P-rock back in there. We have to do an actual fill that is compressible, and we can get some compaction in it. We just can't get compaction in P-rock. The other thing you'll notice is just the minimum footing requirements. These are probably significantly larger than what you're using now. That's just based on the fact that we need to help prevent that wall from wanting to tip over, so that's where the larger footing comes into play. Table 3, this is for your window wells. What do we need to do there? There were provisions included in the previous version of the code for window wells. This just gets a little more detailed into it. Our windows are getting larger and larger. How do we deal with that? Previously in 1975, I'm guessing they were probably 4 feet at most. So now we do have some larger bay windows and whatnot that we're using, and how do we deal with those? So there's options for the 6-inch and 8-inch wall, depending on what your span is. Once again, these are similar but not the same to the bi-level construction. There is no lateral restraint at the top of that wall, nothing preventing it from moving. So what we're doing is taking advantage of the horizontal span and any sidewalls that come into play. So all of the resistance is being handled by the horizontal reinforcing. And that also prevents us from having to do larger footings, because with a 8-9 foot basement height, your footing's probably going to get upwards of 8 to 10 feet to resist all of that force. So that's why we take into account the horizontal span. So once again, you'll see the vertical is just a standard spacing. The horizontal reinforcing is what's going to vary in the window well design. There's also maximum spans. For your reference, those are really clear spans, so inside a wall to inside of the wall would be what those represent. And this detail, similar to what you've seen in the previous versions of the code, shows the damp-proofing requirements, just kind of a repetitive of what we had before for the basement wall. Now we're just showing what the window wall looks like, or window well looks like in relation to that. Other new things that were added, the corner bar details, figure 4A. The original design really focused on the vertical reinforcing and the vertical span of those walls. The thing that wasn't taken into consideration is how we resist all of that force at the top of the wall. So with the new, we've taken into account horizontal reinforcing. That's working to our advantage. So corner bar details are really important. We need to make sure we have continuity of that force or that strength around those corners. In addition, we've got reinforcing and openings, a couple of different options there, depending on how the geometry of your opening is versus the top of your wall. And those just reflect the minimum requirements for ACI 31811. Wall bracing, this is probably a big topic for a lot of you, I know. Why do we need it? Why is it there? We've never had to do this before. It really is providing that transfer we need to get the resistance and stabilize the top of those walls where we have the parallel condition. So I don't know if this confuses the issue more or not, but the red arrows are really trying to define how we're transferring the force. So at the top of the basement wall, you can see there's nothing here to prevent that wall from moving. As this pressure builds, this wall is just going to want to move. And I have seen that before, where it'll move, it'll flex. You know, it might be minimal, but it's moving. It's going to continue to move until it fails to some degree. So the soil pressure is coming here. It's going to transfer the anchors through the plates. We're going to transfer that force. The goal is to get it up here to the sheathing. That's where the resistance is going to be provided. So it's the soil pressure goes through the diagonal brace and then back into the sheathing. And that's when it's going to provide our lateral resistance. So I don't know if that helps at all, but that's really what we're trying to accomplish with this. If our truss is bearing directly on here, that truss is transferring that force back up into the sheathing system. So that's, I guess, all I have. I'm sure time for questions at the end here. Okay.
I don't really have a presentation for you or anything, but basically just kind of discuss with you guys and I brought this for you to basically just tell you guys what we're looking for on the plans. Right now we're looking for essentially the foundation plan to have all the information, your vertical, horizontal, window, well, rebar, which case you're using, case A or B. Just describe it right in a table or in notes on the foundation plan. I know a lot of you guys have been doing it on the section, but I've never seen a section on a footing inspection. So, I mean, I don't even see plot plans actually sometimes. So, I'm not sure how you guys are setting those all the time, but it'd be nice just for continuity to have our inspectors and you guys, all the concrete guys, on the same page as far as what we're looking for. Because I mean, I don't know how you guys are even going to build it without having it all right there on the plan. You know, instead of flipping through one of these every time you go out, we're looking for it on the foundation plan. I know we had talked, I don't know if you guys, the HBA got a list together. Like, I knew you guys were looking for a checklist. We weren't looking for that because, I mean, our checklist is for a plan review is the code, you know. So I don't know if you guys were working on getting some kind of checklist made up and we were going to review it and let you know what we thought about it. But for the most part, I think what we're going to be looking for is as much detail on the foundation plan. You know, you put it right in the middle of the house or on the side on a table, whatever you want to do. But just to get on the same page, I think we want to have it all on the foundation plan. I don't know, were there any questions specifically? I know was thinking you guys might have, were gonna ask Casey, but what,
I don't know. We can open it up for questions if that's what you want to do.
yeah, are there any questions on these tables, or?
The main thing was figure 5, the parallel wall bracing. I thought there was going to be maybe a couple of different options that we were going to try to have the city adopt, so we don't have to pay an engineer every time we do it.
Yeah, well, and I think there is a way to get around it. I mean, there is that 1,020 pounds. I mean, if you can find something that resists that load. I think
We are in the process, the HVA contracted with Sandman Engineering, and we were hoping to have it ready today, but it should be ready. It has to go to the city for approval. But they came up with a mini truss that's gonna sit in there that should work for almost all situations. Some cases it might be overkill, other cases it will be to the max probably, but he just got that to us yesterday, and we'll submit it to the city to look at, and that will be made available to everybody, so that hopefully your truss package then will get, your truss supplier will supply that with his package. The only thing that it kind of screws up is that when you get to your, say, the other end of your house, when you're laying out your trusses, you'll probably have to back up your truss layout so that you can get the same spacing on those last 2 rows, whatever it takes to get it in there. But hopefully we have that within probably a week.
Is that kind of the stuff Mitch was talking about with not,
Okeson?
yeah, not being able to move anything for plumbing, have to kind of work with plumbing, because those end trusses are going to have to stay where they're at, you can't adjust them really?
Well, I think that there probably could be some minor adjustment. Casey and I talked about that yesterday, about if you, let's just say you got a jog in your foundation wall, and your layout comes, and you got those trusses coming, and your layout in that jog is, you say you've got a truss now that's only 8 inches away from your outside wall. We'll have to figure out how that's going to get handled, whether it's maybe solid blocking or something.
Sure.
But for the most part, we're hoping that this little, I'm going to call it just a little mini truss that drops in there. We actually got a draft of it yesterday, and hopefully we get that to you within shortly after Memorial Day.
Is it going to possibly be maybe adopted kind of like Memorial has it, where he's lock-free out, or?
You know, it's, I think depending on the depth of your trusses, if, you know, the deeper your trusses, the more likely you're going to have to go further in because of the angle.
Sure.
And, hopefully that helps the situation, because this detail that is in here is actually pretty cumbersome to work with.
Yeah.
And so we're hoping that this will solve the issue and keep the city happy and still provide the...
Make the numbers work, yeah. All right, sounds good.
And that was a big topic of discussion during all the meetings that we had, and it was my preference to leave that detail out altogether and allow you guys to come up with what works for you. I would give you the loads, and you would develop that works for you. I agree that puts more pressure back on you guys, but as you can see, there's no home that's the same. There's no condition. I mean, there's so many different things. It's like, you know, throwing a dart and hoping for the best. So we were asked to put something in. This is what we came up with. It's conventional construction. I mean, from the standpoint of you can put 2-by material in there and make it work. As John said, it probably is really cumbersome.
Field-wise, I think it's nearly impossible, but.
Well, like I say, it was the detail that we said, you know, hey, what about this concept? Yeah, let's throw it in there, and I agree. It was not our preference to put something in there, because at that point in time, then, you know, it's not a fix-all for everything.
Okay.
James, I think as we get into this more, I still think we want to develop a checklist, whether we do this after we've been doing this, so that as a builder and as you work with your concrete. The biggest thing here is, and just so people understand the little bit of the logic going back to when we started working on this, we dumped a lot of this responsibility on the concrete people because we felt that if one contractor could do most of this. Right now, the biggest thing that we have to do is those end wall braces as the building contractor. So we put a lot of the pressure back on the concrete people the design is in their hands. So I think, again, your relationship with your concrete person is gonna be critical, that everybody knows what has to be required. And that's where I'm hoping that we still come up with a checklist to help everybody through this process to say, okay, and a lot of the concrete people will probably look at your plan and they'll be telling the builder what he's got to do. I mean, that's probably what's going to happen, is the concrete people are the ones that are going to help you work kind of hand in hand with the design of that foundation, so that we don't have any trouble with the city.
Is this a checklist when you submit your application that you want?
No, well, it's probably more a checklist. It's kind of a double fold there also, so that we know. I mean, I know, I'd still like to get one back from the city that helps us, you know, the things that you're gonna be looking for. I guess you're gonna have to have those details on there, but still, it's just a reminder to everybody what they've gotta do. And then also, in the design process, just things to look for, like, if you have a wall length over a certain length, you're gonna have to probably put a buttress in it, or do something.
You have the start of a checklist on the